Good afternoon, everyone. My name is John Einkoff. I'm the Senior Product Manager for Amazon Elastic MapReduce. The topic of this session is the Hadoop ecosystem. It's going to last about 50 minutes. There will be 3 different speakers. Myself, Ted Dunning, the Chief Architect from MapR, and Ronan Schwartz from the VP of Product at Informatica. We each have very different things to talk about, but they're all related to the Hadoop ecosystem. We hope that this will be useful for all of you. For my piece, I'm going to talk for a few minutes about what is Amazon Elastic MapReduce. I'll assume that you have a basic understanding of what it is, given that this is a 200-level session. But I'll go over it at a high level, and then we'll talk a little bit about the Hadoop ecosystem, as well as kind of EMR's role within that ecosystem. And then I'll let Ted and Ronan introduce their topics, which I think are very interesting, and again, relate to the Hadoop ecosystem broadly. So first of all, what is EMR? So can I just see with a raise of your hands, how many of you have ever used Hadoop? Okay, I'm hoping most people, great. How many of you have launched an EMR cluster, Elastic MapReduce cluster? Show of hands. So it looks like maybe a third of the room or so. So EMR, very high level, is Hadoop running in the Amazon cloud. Hadoop is, and this is probably all I'll say about Hadoop, it's an open source platform for massive parallel processing across many, many different machines. And again, I think that there is an intro level EMR course, and I think they're going to repeat the session tomorrow. So if you're looking for more of the basics of what Hadoop is, what MapReduce is, I would strongly encourage you to check out that session. There's also information online on our website. But for our purposes, just kind of think of it as massive parallel processing across many, many nodes. And in our case, those nodes are EC2 instances in the cloud. Amazon Elastic MapReduce, or EMR as it's commonly abbreviated, is run in many different industries and has a wide variety of use cases. So everything from media companies and advertising companies optimizing their advertising ROI, to retail companies like Amazon.com developing recommendations and personalization, to financial services companies calculating risk, to mobile companies looking at user behavior on a mobile device. So we see a lot of gaming and advertising and kind of mobile and tablet applications. We have thousands of customers around the world. We're also very, we've run 2 million clusters just in the last 12 months. If you were at the keynote this morning, you probably saw the exponential chart of the number of EMR clusters that have been launched. We've been doing this for a while now. We started in 2009. And as I said, we're used by thousands of customers around the world. This is a small sampling of who runs their Hadoop jobs using EMR. And I'll just comment on one of them in particular. Amazon.com is actually a huge user of Elastic MapReduce. There are hundreds of teams all over the company that use EMR for everything from developing the recommendations that you see when you go to Amazon.com to figuring out the optimal routing of packages. If you think about that problem, it's a very complex problem, and Hadoop can really bear a lot of fruit when you apply it to that issue. Also, everything from identifying fraudulent buyers and sellers, looking at things that are happening in the warehouse, advertising ROI, kind of whatever you can think of, chances are there's a team at Amazon that's using EMR for that purpose, which is really cool for us, and we like to see that internal usage. So, and I'll do this at a very high level because, again, this is a 200-level session, but at a very high level, customers, and I'll describe one very common model here. Customers will put their data into S3, which is Amazon's simple storage service, very cheap, highly durable storage. Next, they make some decisions. So they decide which Hadoop distribution they want to run. And we provide a number of options. You can run MapR M3, you can run MapR M5. There's an Amazon distribution. And the Amazon distribution, by the way, is basically Apache Hadoop that has been extended and modified to make it work really well in the cloud. But so you decide which distribution you want to run. You choose how many nodes you want to have in your cluster. So it could be everything from 2 or 3 nodes, which we see a lot of, to hundreds or even thousands of nodes, and we see a lot of those as well. In addition to the number of nodes, you also choose what types of nodes. So if you're familiar with EC2, which I assume most of you guys are already, We have different families of instances. Some of them are high CPU, some are high memory, some are optimized for disk, some are better for networking. It's really kind of application dependent, and based on what your needs are, you would choose what instance you want to have as one of your cluster nodes. In addition to that, you have root access, and you can make configuration changes, change settings like the Java heap size, and kind of whatever you need to do to optimize and control and make changes to your cluster. You would make those decisions up front, but you could also change it later on. And then in addition, you would make decisions about what other technologies you want to install as part of your EMR cluster. So for example, do you want to install and run Hive? Do you want to run Pig? Do you want to run HBase? And you have to make that decision, and we make it very easy to, once you've made the decision, install and run those services. Once you've made all of those decisions, you go to the EMR service and you launch your cluster. And you have a variety of tools that you can use to launch your cluster. You can use our web GUI that we call our management console. You can use the command line interface. We have a Ruby CLI that you can use. We also have a variety of SDKs and APIs, so it's sort of up to you what you're most comfortable with. We provide a variety of options for actually launching and managing your clusters. So now you've put your data in S3. You've made some decisions about what you want to do with the data. You've launched your cluster using the EMR service. The EMR service starts to provision EC2 instances. We install Hadoop. We install our patches, other software that you want to install. So we get the cluster going. The cluster will start pulling that data in from S3. It will start processing it. When the processing is complete, the output is sent back to S3 where you can pick it up. Now, that's one model for what customers will do with EMR. There's another very common model, which is they skip S3, and they put all of the data on HDFS, and they leave it there. They keep the cluster up all the time. And that's an option for you. And actually, we have some customers that do both. For some jobs, they will put the data in S3. They'll spin up their cluster, do the processing, shut the cluster down. You stop paying for it. We have other customers who want to have, and Netflix is an example of this, where you have a several hundred node cluster, and they keep it up all the time, and they keep their data in HDFS, and they're continuously scanning against it. And actually, customers like Netflix actually do both. Some clusters they keep up, and they use HDFS. Others, they keep it in S3. Spin up clusters and shut them down. It's really up to you. Now, one of the things that you can do with Elastic MapReduce, and generally one of the cool things about doing Hadoop in the cloud, is that you can scale your cluster. So let's say you have an application, and you need normally about 100 nodes to do your processing, steady state. And maybe that's to process 24 hours of data. But let's say now you have to process a month worth of data or a year's worth of data. You don't want to use that same 100-node cluster. You can take that cluster and you can almost instantly scale it. And then when you're done, you scale it back down. And of course, with the cloud, you only paid for what you used. It's as simple here as a very quick command line argument. And by the way, when you're rescaling your cluster, one of the very, very powerful things about EMR, and I hope that you guys are thinking about this if you're using EMR, is you can use spot nodes for this. So if you're familiar with Spot, you know that you're basically bidding on unused EC2 capacity. You're oftentimes paying pennies on the dollar for those nodes. So imagine going back to that scenario where you've got your 100-node cluster, and you want to scale it up to 500 nodes. Well, those 400 nodes that you want to add in, those could be spot nodes. And that's a way of speeding up your job dramatically, but also dramatically lowering your costs because you're only paying pennies on the dollar. Many of our customers are using Spot, but many are actually still not aware that that's a possibility. So I would definitely encourage you to think about that if you are yourselves running EMR. Now, when you're done with the processing, you can shut the cluster down. That's one of the really, really cool things about EMR. And of course, once the cluster is shut down, you stop paying for it. But going back to what I was saying earlier, that's one model. A lot of customers spin up their clusters, they do their processing, and then they shut it down. Many other customers keep their cluster up all the time, and again, they store the data in HDFS, and it's always there. And then there are some customers that do both. They have both models. So at a high level, what we're trying to do with this service is provide you options. Options and control. So it is up to you to decide how many nodes you want in your cluster. What types of nodes? Do you want high CPU? Do you want high memory? Do you want to have like a small cluster now and resize it, or do you want to have many small clusters? It's completely up to you. We let you choose, and we encourage you to choose which distribution is best for your options. MapR has done some really great work to make Hadoop very enterprise ready, and there's some really cool features in the MapR distributions, and we're really excited that that's an option for our customers when they come to our service. You also have a choice of Hadoop components. So I mentioned earlier, you could very easily install and run Hive. You could run Pig. You could run HBase. And there's a variety of other things that you could run with Hadoop. So although our name is MapReduce, we're really about enabling much more than that. We're trying to make it really easy to use all of these other Hadoop components that are part of the Hadoop ecosystem. So we're trying to make that as easy as possible. We also want you to have a choice of tools. So we provide the ODBC and JDBC drivers, and we provide integration with a wide variety of non-Amazon tools. So if you have a BI tool that you like, or you have a visualization tool that you like, as long as it works with Apache Hadoop, it will work with Elastic MapReduce. And finally, we have a concept called bootstrap actions, which is a little bit different. It's something that we invented. And the idea of this is that you write a script. You store that script in S3, and the script essentially has instructions for installing or running anything you want, basically. So you could use that to install additional software. You could use it to change some of the Hadoop default settings. Basically, it's anything you want. When the EMR service launches the cluster, we will ask you for the location of the script if you want to provide one. And when we're provisioning the instances, we'll grab the script, execute the instructions, and we'll do that before Hadoop starts running. So through the bootstrap action, and you can use multiple bootstrap actions, you have really complete control over everything that's going on in your cluster. So again, it's about options and it's about control. Now let's talk a little bit about the Hadoop ecosystem. So at core Hadoop really consists of, in my view, two things. There's MapReduce and there's HDFS. So HDFS, and again, I'm going to go through this at a fairly high level, so I hope that's OK for this group. HDFS is the Hadoop distributed file system. MapReduce is the computational model within Hadoop. When you pair the two together, that's where you really get the power of this parallel processing, where you can take a job and get it done much faster, and you really see the power of big data. And that's kind of where it started, but over time, a variety of other tools and technologies have been added to the ecosystem that, for example, make it easier to get your data into Hadoop, that make it easier to connect your Hadoop cluster with a relational database. You see some of the logos up here help with serialization and deserialization, monitoring of your cluster. So if you think about over time, the number of tools and technologies available to you in the ecosystem has really grown explosively, and we're very excited about that growth. And on this slide, you're only seeing a small slice of the tools and technologies that are now part of this ecosystem. I think really broadly defined, the Hadoop ecosystem is what you're seeing on the screen here, but it's also all of the non-open source tools and technologies that are out there. It's the open source tools that are not officially related to Apache Hadoop that people are starting to use with Hadoop, like R. And it's a very exciting space. It's growing very rapidly. And we're very excited to see that. And you're going to hear in a moment from Ted and Ronan. They're going to talk to you about some of the other tools and technologies that are part of this ecosystem. For the thing I'll say about from the Elastic MapReduce perspective is we want to make it really easy for you to run these tools and to experiment with things as they come out. A lot of the tools that are out there are very new. Some of them are relatively immature right now. But we want you to be able to experiment cheaply and quickly with them. So to that, I want to show you some examples of some of these tools in particular and how you would actually run them with Elastic MapReduce. So Hive is probably one of the oldest technologies that complement Hadoop. It is essentially a data warehouse for Hadoop. It provides a SQL-like query language that if you're familiar with SQL, you'll probably find HiveQL pretty familiar. There's some nuanced differences, but generally they're very similar. And we find many, many customers using Hive. Pig is another one that is Apache Pig. This is a very, very commonly used programming language. It's really great for ETL and data flow type processing. It supports user-defined functions, so it's quite flexible and extensible. I would say of all of the Hadoop ecosystem components, these are the two that are probably the most popular, the most common, the most tried. If you're not using one or both of these today, I would definitely encourage you to check them out. By the way, both of these are available as an option in a drop-down box when you're launching your EMR cluster. So you don't need to worry about getting the code and installing it and configuring it. You literally, if you're using the web GUI, you select Hive in the drop-down. Or if you're launching your cluster from the command line, it's an additional argument. Again, very, very simple. So that's Hive and Pig. HBase is a column-oriented database that's really ideal for when you have billions of rows, millions of columns. It provides random read-write access, and it's really great for sparse data. So in particular, where I see customers using HBase is for analytics applications. But there's a wide variety of use cases. If you're not familiar with HBase, I think this is also something that you should probably check out. Mahout is a machine learning library for Hadoop. It comes pre-installed on your cluster, so again, there's nothing to install. It's right there, ready for you to use. It's especially good for things like recommendations, item classifications, things like that. If you're looking at machine learning, this would be a good thing for you to evaluate. Now, in addition, there's a wide variety of other tools and technologies that we try to enable and try to make really simple to run with EMR. One of them is Ganglia. So Ganglia is used to do monitoring of your cluster. So you can look at cluster-level information, node-level information. And the way you run Ganglia with Elastic MapReduce is you install it through a bootstrap action. So that's the script that I was talking about earlier. And we provide the script. You don't have to write anything. All you have to do when you launch the cluster is specify the location of the script that we give you, and we will do all the work for you. R is something that we're starting to see more and more commonly used with Hadoop. I think probably most people in the room are familiar with this as the very, very powerful language and software environment for essentially statistical computing. Very, very powerful, especially when you do it in conjunction with Hadoop. So we see some customers using it, for example, to do stochastic modeling on Hadoop. Very, very cool. We're very excited about that. The last stable version of R is like Mahout, available on the cluster, pre-installed. You don't need to worry about having to install it. So now I'm just going to give you a few examples of what it looks like to actually use these technologies, just to give you a flavor for what it takes to launch them. So if you wanted to launch a Hadoop cluster from the command line interface, you would write Elastic MapReduce -- create. That's actually all you need. I've added some additional arguments here just to give you a flavor for other things you can do from the command line. These other arguments here, -- alive means that the cluster will stay up even after the job is finished processing. And you can see here that we're specifying that we want 5 nodes, and we want those nodes to be m1.xlarge. That's basically our standard instance family. It's the largest in that family. I think it comes with about 1.5 terabytes of local disk. And as I mentioned earlier, there's a wide variety of instance types, and you would need to choose ahead of time what you want to run. So that's a standard Hadoop cluster. So what does it take to launch a Hive cluster? And again, here I've added some additional optional arguments, but you basically are writing Elastic MapReduce -- create. You can see here we're specifying a Hadoop version. We're specifying how many nodes, what type of node. We're specifying the Hive version. So hopefully you would agree with me. It's pretty simple to launch a Hive cluster, and we provide you the ability to choose all of these things, like how many nodes and which version of Hive, things like that. So that's Hive. What about HBase? So once again, Elastic MapReduce -- create, and the difference here is -- HBase. That's all you need. Here we're naming the HBase cluster. We're saying how many nodes, and we're giving it the cc2.8 extra large. That is one of our cluster compute instance types. And again, depending on your application, that may be the right instance for you, but you could run on any of the other instance types as well. All right, what about Ganglia? So this is one where you install it through a bootstrap action. So what that looks like is Elastic MapReduce -- create, and then bootstrap action, and then you can see here, this is the location of the bootstrap action in S3, and we have written it for you. You just need to specify this at launch. And what EMR will do is it will go to that location in S3, it will pull the script, execute it, and it will do all of that before Hadoop starts running. And finally, so the last few examples were from the command line interface. Another very common model is customers like to use the management console. So what we're looking at here is the wizard for launching a new job flow. There are 5 screens. So on the first screen here, you're specifying the name of your job flow. You choose which Hadoop distribution you want to run. And then here, we're selecting Hive from the dropdown. So fairly simple. If you wanted to run a custom jar, if you wanted to run HBase, you would just select the appropriate option here. That's the first screen. On the second screen, and in this example, what we're running is a Hive cluster, a cluster running Hive. So on the next screen, what we're selecting here is that we want to execute the script rather than launching the cluster and keeping it open for an interactive session. And then what you're seeing in the options here is what is the location of your Hive script? Where is the data, the input data? Where do you want EMR to put the output data? And do you have any extra arguments that you want to pass in? On the next screen, this is where you choose the number and types of instances that you want to run. We have 3 different types of instances or 3 different types of nodes in your Hadoop cluster. There's the master node, there is a group of core nodes, and then there's a group of task nodes. The difference between core and task is that task does not include HDFS. It's purely to help with the computation. It speeds up the processing. There is HDFS data on the core group. And here what we're selecting is what instance type, the number, and here is where you would actually specify, do you want to use spot? The next screen is advanced options. So if you're an AWS customer of EC2, you probably already have a key pair. You could specify the name of your key pair here if you wanted to SSH into the master node, which can be very useful. If you want to persist your logs to S3 for debugging purposes, if you want to keep the cluster alive or not, there's sort of a variety of advanced options here for you. And then finally, this is where you would specify the location of a bootstrap script, a bootstrap action that you want us to run. So if we had selected this radio button, it would basically just ask you for the location of that script. Then you hit next, and your cluster will start launching. And that's the same for if you're launching a 2-node cluster or if you're launching 2,000 nodes. The cluster will launch, and then you'll be brought to our management dashboard where you'll have information on each of your clusters, the health, how long it's been running, things like that. And if it's all right with the group, we're going to take questions at the end. I think that we probably will have time, so if you could just save that. Last thing, I'll go through this very quickly, and then I want to hand over the mic. High-level key benefits of using Elastic MapReduce. It's very easy to get started. You can literally launch your first cluster in less than a minute. It's particularly easy if you're already an AWS customer because you already have a key pair. You're kind of already set. It's easy to scale up and down. You can go from 2 nodes to 2,000 nodes in minutes. You only pay for what you use. So there's very little risk that you're going to spend money on all of this infrastructure up front and then decide a few months later that you kind of made the wrong decision and there's some sort of a problem. You can launch parallel clusters that are pointing at the same data. So Netflix does this, for example, where they have their data in S3 and they launch multiple parallel clusters, each pointing at and using the same data. They'll have one cluster for their production systems, one for their analysts, for their people that are doing queries like which videos are the most common right now, which videos kind of have the highest latency issues, maybe another cluster where they're doing kind of ad hoc analyses. The ability to launch these parallel clusters is one of the key reasons why Netflix loves running on Elastic MapReduce. If your needs change, and I was talking about this a moment ago, it's very easy to change. You can shut down the cluster, you can start a new one, you can change the size, the node type, the Hadoop version. It's really simple to do that. We integrate with DynamoDB, EC2, S3, VPC, CloudWatch. So if you're familiar with those services, if you're using them, you'll find that there's very seamless connectivity and integration between us and their services. Because we give you root access and bootstrap actions, it means that you are in complete control of your cluster. So if you want to, you can tune it and optimize it and do whatever you need to do to make it sing for you. We provide you that ability. And finally, what we're trying to do at the core is we're trying to make it so that you don't need to worry about launching and managing, configuring Hadoop. We know that that's complicated, that's hard work, and it's frankly not probably part of the core value that you can bring in your business. What you really want to do, I'm guessing, is get value out of your data. And so we want to take that heavy lifting off your shoulders and make it as simple and as easy to do as possible. So that's Elastic MapReduce. I'd like to introduce Ronan Schwartz, who's a VP of Product at Informatica. He's going to talk to you a little bit about HParser and some other very interesting things. So if you could please welcome Ronan.
Thank you, everybody, and I'm really glad to be here. My first question to you is, how many of you are familiar with Informatica? Maybe I can see, okay, I have maybe about a third of that. So Informatica have been the pioneer of an area called ETL, Extract, Transform, and Load, that later on have been developed into what is called today data integration. And if you're asking analysts, large customers, and small customers as well, Informatica is pretty much there at the edge of a very key technology that is bringing data into the data warehousing, bringing data into analytics, making data available between applications. I'm very lucky to be here in front of you today because it seems like data warehousing is getting to be more relevant for this community than ever before. Informatica is key technology in enabling that. Well, Informatica started as a pioneer in the ETL space. One of the areas of growth was with supplying a lot of services around the data integration that are critical to bring the data in the right way so that you can actually leverage it afterwards in application analytics. Things like data transformation. How do I take files into a structure? Things like exchanging data, bringing data from external sources, masking, quality, MDM, and so on. This is kind of building the Informatica platform. And I'm really pleased to share with you that about 12 months ago, we have started bringing this technology to be fully available on EMR. And what I'm here to share with you today is how one of these technologies, HParser, is working on Hadoop in general and specifically optimized to work on Elastic MapReduce. So if we're looking into the Hadoop problem in a very, very simplistic way, we can look at it as a source, a map and reduce actions, and then a target. And the source can be on HDFS, it can be on S3, but it's basically there is a source, there is a target, and then a MapReduce set of actions. When a lot of this technology was developed, the sources were extremely simple, mainly Apache logs or logs in general, very flattened, at least in the initial look into them. But a lot of the real-world data is more complex than that. It's not actually clear where does the record start, where does the record end, how to define it, how to translate the data. The data is binary, not necessarily textual. This real problem is sometimes underestimated. And when I thought about which example should I share with you, I had a bunch of examples. But those of you that were on the lunch area, you saw how hard it is to parallel 5,000 or 6,000 people getting into one lunch area, right? Even though they had all of these different stations, we still had a bottleneck. And sometimes this bottleneck, if you're doing MapReduce, is actually in how to take the real-life data and make it available to be parallelized. How do you flatten it so that then the map and reduce is becoming effective? This is where HParser is playing a role, and it's giving you a few things doing that. It is actually giving you a visual environment to define how to flatten this data. It is supporting any format, not just textual format. It supports things like XML, JSON. It supports things like Word documents and PDF, Excel files. It does support industry standards, and it does support also the logs and from a variety of formats. So supporting any format, supporting complexity in the format, but also in the data structure, and easily embeddable inside your process. Because it is becoming a natural MapReduce step available on EMR. If we're looking into the design environment, it's basically include a few components. We're allowing you to develop the transformation or the rules how to flatten the data while you're looking into a sample data. So what you see on the right side of the screen is a sample of the data, and then in a simple drag and drop process, you're basically developing the rules how to extract the data. When you're doing that, the data is starting to get highlighted, so you're seeing whether you're successful or not. You don't have to compile it and run it. You can, on the spot, see the input, the output, and how does the data look on the source itself. So you can take in here any data, binary or non-binary, documents or blob, and really convert that into a data that will be very simple to do MapReduce processes afterwards. So basically, if you look into the end-to-end process, we're taking a sample data, multiple files as the input, and we are aiming at creating a well-structured output. The example that I'm going to talk about is actually going to be a telco example, but every one of the industries shared earlier actually have its own set of challenging data sets. If we're looking into the telco industry, they have one of the ugliest formats that you can define called ASN1. It is a COBOL-like compression that is very important so that you can move the data from the switches to a central location. We're allowing you to actually take this input file, put it on the source side, and create on the other side a well-flat textual file that you can do in a MapReduce. So first you are developing this transformation in the design environment, and then basically you are deploying it to run as part of your MapReduce processes, usually in the map step. There are a few optimizations that are done to make it easy, because one of the other challenges that happens is that the file format change. The data sources that you want to integrate into your application, into analytics, they change. And you don't want to need to do a complex compilation. You don't want to do a complex redeployment. So basically, the transformation rules are within a simple file that you can share quickly with the cluster itself. So the value proposition is real-world data, flat file logs, hierarchical data like XML, JSON, Avro, and so on. Full support for industry standards, so there are thousands of predefined transformations that handle the complexity of a variety of verticals: financial services, banking and insurance, healthcare, telco, manufacturing and retail, and so on and so forth. And also full support for documents, including the binary ones that are a bit older, the XML ones that are newer, and so on. When we're talking about transformation, the problems that I defined are sufficient. But when we're looking into Hadoop, the next part is, does it scale? I want to share with you two charts here. I'm not to blame for creating this chart, but the axes are definitely not helping me showing the graph as a linear graph. It actually shows it a bit better. But basically what I'm trying to share with you is that with HParser, you can not only scale, you can also predict how much compute would you need in order to transform the data. So basically, you can see here how much does it take us to process 10 gigabytes from a much larger data set. How much does it take us to process 50 gigabytes from a much larger data set of telco binary format. So all the data here need to go through a similar process to an encrypt-decrypt from the binary format and then be normalized and flattened. This is kind of showing you how will you be able to do it on a growing amount of nodes. Another problem that you sometimes have is you have a windows of time in which you need to process a certain amount of data. So the following chart is showing you on a 72-node cluster how much data are you able to process, and showing you what is the amount of data that you can process within a known window of time. Where we've actually optimized the software is in making sure that it is fully scaling per the nodes and that it does support unlimited data sets. It does include the ability to support not only large amount of small files, it also supports large files with built-in streaming capabilities and optimized parallelism afterwards. My last slide is actually going to tell you this is available for you on EMR. It is optimized to make your install easy as part of the bootstrap option. So you can really point as shown earlier and get that working for you. It is available in a community edition, which is a freeware to support weblogs, XML, JSON, and other formats. And you can download it by simply searching HParser Community Edition or Amazon HParser. It does come with a full tutorial that gives you examples of how does that work. And you can buy more content, more capabilities, Informatica support for the full edition. This was my part done quickly, and this will be a good time for me to introduce Ted Downing, Chief Application Architect at MapR.
Commonly known as the guy in the red hat, which is often true. I had a bad situation the other day when my wife didn't recognize me because I took my hat off. But that doesn't happen all the time. So what I want to talk about is two particular things that are happening, partly with MapR, but partly in a larger community. One is the new Apache Drill project. Back up, sorry. Apache Drill is intended for low latency interactive queries. A second, and it's open source. There's hundreds of people involved in this across the US, Europe. There's some people now beginning to work on it in Asia as well. The goal is to develop community consensus around what this sort of API needs to be and what sort of functionality is really needed. We expect a very early prototype release this quarter, this being Q4, and more realistic releases next quarter. So the problem here is that latency really matters. You saw on Ronan's slides that these data conversion jobs running MapReduce things have a little caveat there with a 1-minute startup time and a 1-minute tail off time. And that's very typical of a MapReduce environment. It's nothing to do with Informatica. And it's based on the fact that Hadoop MapReduce especially is intended for large batch operations. And therefore, a bit of overhead, a minute to start the program, it's not that big a deal. Well, it is that big a deal if I type a query or I try to hit a dashboard page and I ask for data. It's just not acceptable to be waiting as long as it takes to spin up a batch job. It's also not acceptable to not take some of the economies that are possible in a query language, such as column-oriented database. And so we feel that there's, a lot of people feel this way too, that there's a lot of scope for kind of the missing bit out of the open source thing. The batch processing over on the left, we've got pretty well covered with Hadoop, MapReduce. The real-time stream processing, the open source community has pretty well covered with things like Storm or Apache S4. But there's a middle ground where we're not actually doing streaming. On the streaming side, we have fixed queries that are defined ahead of time before the stream starts. On the batch side, we have interactive queries, but large overheads. There's a missing bit in the middle where we want to have the flexibility of the batch sort of thing, but some of the interactivity of the stream-oriented real-time stuff. And that's where Drill is fitting. That's where, at Google, the Dremel project filled that gap, but there is no good, truly open source Apache-like project for that whole. So one of the goals of Drill is to be highly flexible. And initially we'll have an SQL-like language, but adapted for nested data. Nested data is commonly used in big data applications to denormalize what would otherwise be relational data with linking tables and things like that. Other options include for later things like the Mongo query language, which is widely used purely because MongoDB itself is used. And we want to make it easy to plug in new languages. If you'd like to clone the Pig Latin, then that should be very easy to do. The data model is also nested. Instead of a relational sort of thing, we want to have records that have arrays of records inside them. And we expect to be supporting multiple formats there: Avro, protobufs, JSON, things like that. JSON in various binary formats. And flat files, of course, rectangular flat files are a special case of this, where we don't need to nest anything. We want Drill to be highly extensible. Right now, most of the action is going on around specifying the abstract internal representations for both the logical plan and the physical execution plan so that anybody can drive to those formats from any language or any generation format that they like, and drive from the execution plan into any kind of scanner or data processor that they happen to have. The flexibility there is intended to be very, very, very large, very easy. It also lets different people who specialize in different things. If I specialize in a web interface, I shouldn't have to know about code generation in the extension language. The design goals are easy, dependable, fast. That's because a lot of MapR developers are involved. But flexible is a very high goal as well. We want to be pluggable. We want it to be easy, that you can unzip and run. My ideal view is that this not only scales to thousands of nodes for very large problems, but it scales down as well. Why not have the ultimate grep here that supports a nice language, and it can read interesting structured data, and it runs on my laptop? I shouldn't need a cluster. I shouldn't need an involved installation. It should just be zero conf, away and we go. Fast, there'll probably be a C++ core for some kinds of scanners, but flexible will also imply Java-based cores as well. We want to minimize latency, maximize throughput for flexible queries. I'd like to also talk now about a second thing, which is big and exciting, and that's much less open sourcey, not so much, boy, if I just touch this thing, it does that. I think there's a shake detector in it or something. So this is an extension to the MapR platform. It should be hitting EMR before too long. But the basic idea is that we integrate key value store capabilities, columnar database, directly into the advanced data platform that's already part of MapR's M5. We get rid of concepts from HBase like region servers and manual splits or compactions. We support snapshots. We support mirrors with this. Very high throughput, no garbage collection overhead, very consistent, low latency. It's designed to be HBase compatible, but a simpler architecture. So with MapR using HBase, you have multiple layers with Hadoop using HBase, you have multiple layers. With MapR using HBase, you have fewer layers because you put HBase directly on the MapR file system. But with M7, you'll have the fewest number possible because the key value store is integrated directly in the data platform. We have some comments from early views from some of our customers. Rubicon is one of the largest independent ad networks. This thing keeps advancing. So they talk about M7 taking HBase and Hadoop to the next level. It integrates these capabilities that are so commonly needed. Ancestry.com is a surprisingly large data user because they have data from all these genealogical records. Melinda said she was very, very excited about what she saw in this. And Return Path, where they're doing email intelligence applications, big win for them because they have to deal with a very dynamic world. What's happening in email delivery changes moment by moment. Their analysts have to be able to look at very large volumes of data in an ad hoc way. So the summary then is that it's fully integrated into the data platform that's inside MapR, API compatible with HBase, and highly available, very stable, and very good latency, that very well-known latency as well. The integration gives you things like snapshots, and you'll be able to take a snapshot, full operation, no interruptions, and access the snapshot as a table at any time. Be able to do mirrors to deploy copies of the table or for backups. No single point of failure, of course, and crash recovery in milliseconds. And so there'll be more available. Well, I guess this is John's slide. If you have more questions, we'll have a little bit of time. We are 8 minutes to go. Yeah, why don't we pull everybody up here? Also, later today at 3 o'clock, I'll be signing copies, complimentary copies of Mahout in Action. If you're interested in Mahout, try the book, try EMR, let's get going. And of course, I'll be there to answer further questions if you like. at the MapR booth? That is a really good question. Thank you so much. That's at booth 131. It's right next to the big stage in the vendor area.
I believe that Informatica, you also have a booth downstairs. So I think we have...
I think Amazon has a booth downstairs, too.
Yeah, I think so. So we have about 6 or 7 minutes. Just before we do that, what I wanted to put on the slide here is if you want to learn more about Elastic MapReduce, you can go to our website. We have video tutorials, documentation, frequently asked questions. So if you're sort of just getting started or you're looking to get more advanced, that's probably your best bet. So why don't we, and then last thing I need to do is to ask that you please submit feedback on the session. We'd love to hear from you how we can improve this for next year. And so now we have about 6 or 7 minutes. We'd love to take some questions. So just raise your hand and we'll try to see you and call. So I see a hand right here.
I have a question for Roland. I was interested in the Informatica mentioned. We have various proprietary formats. I'm wondering if you have developer licensing for one that's able to use proprietary formats available for low cost, but have to sell it so to speak. Or does the community edition allow building the proprietary transformations?
If you could repeat that.
Yeah, so the question was what is supported, I'll simplify the question. The question was what is supported within the Informatica Community Edition, and is the cost reasonable to sell internally for those of you that want to develop a custom transformation inside the HParser. So the Community Edition does give you good support for development of proprietary format, as long as you are not going into the complex binaries and the proprietary industry formats which we are maintaining on a regular basis. The Community Edition should be a good place to start.
Why don't we take a question maybe over here in the red hat?
A question before when you were going through real quick the EMR deployment, you showed the CLI and the web UI. Is everything you see in the web UI supported by the CLI, including
Generally, everything that you can do in the web, so everything you can do in the web UI, you can do with the CLI. There are some things you can do in the CLI that are not currently supported in the web UI, but very shortly we're aiming to have complete parity between the two. The most advanced features, the newest stuff, will always hit the CLI. So if that's what you're using, that's probably what I'd recommend.
More red hats.
I'm curious about when you say R with EMR, is that a special distribution that allows it to contribute to?
R has a number of capabilities which you can install packages for integration with Hadoop. That situation is in flux, and it's really not super great yet. The best use I've seen of R with Hadoop is where you have replication, where you're doing parameter scans on hyperparameters, things like that. So you just want to run a small R program many times, typically against the same data. That works well.
So like, so stochastic modeling is a great example where you're running the same simulation many, maybe millions of times, and you're just running that on every node. Sorry, I think I misheard you earlier. I thought you were asking a question about MapR.
No, R.
So, great.
But I do R as well, so
Yeah,
it's
great.
okay.
Okay.
There's one additional thing, and that is with MapR, you can use NFS to directly access cluster storage, and so then R programs can communicate more easily.
We'll have a tutorial on the website as well in the next couple of days to kind of walk you through an example of using R, if that's something you're curious about. See a question right here? So today you have 3 options. There's the Amazon standard distribution, M3, and M5. I think between those 3, you'll find most of what you need. We're very excited about the other distributions. Who's to say in the future? Yeah, in the back, red hat.
Are you able to add or remove nodes from a cluster once it's launched?
Yes.
There's some caveats to that sort of operation. You have to be careful how you do it so you don't lose all of the replicas of certain kind of data. You may need to position the data, or you may want to only add and remove dataless task tracker nodes. But Yes.
And obviously, one of the things that's really nice about Hadoop is it's designed to handle the loss or the addition of nodes. So you might want to yourself be kind of resizing, but you might also be in a situation where you lose some nodes for whatever reason, and Hadoop is perfectly designed for that.
Is this an operation you perform like through the command line interface? Or
Yes.
the web, or is that something you have to go to one of the nodes to do?
You'd use the command line interface to add and subtract nodes. And you would also choose what types of nodes. And as I mentioned earlier, do you want to add spot nodes, which could be a really great, very powerful way to save money.
So you mentioned about bootstrapping scripts. Do you also have scripts that you can execute when I remove it? No?
I'm sorry, a script where you can...
That I can execute like at the time of removal or shutdown of a particular node?
I think I understand.
Shutdown hook.
I'm sorry?
A shutdown hook.
Yeah, so I mean, you can build that into your application that you want to add and subtract at different points in your processing. But you can also do it kind of at a certain point in time if you want to add or subtract. Sorry, maybe I'm not completely understanding the question.
The nodes can terminate themselves. So if you can execute a script on the node, then you can terminate Hadoop, you can terminate the node, you're all good to go there. Yeah, the purpose of a startup script is to run before Hadoop starts. But afterwards, there's no symmetry there. That you can do it anytime you like.
Generally, where we see people resizing clusters is they know that, like with Netflix, for example, when it's Saturday night, they have, and it's either done dynamically or it's somebody actually at the command line that is resizing that cluster. That's typically how it's happening. But you could also write it into your processing that at a certain step you want to kind of resize. See a hand here?
So it is possible to dynamically add and subtract nodes using some sort of command line interface?
Yeah, and if you have questions about resizing clusters, I would love to. I'll be at the booth downstairs later, and I can actually show you examples of the actual code you'd use to do that. I think we have time for maybe one more question. I see a hand in the back there.
I had a question about drill. What is drill Impala?
The question is, how does drill compare with Impala? Impala is further along. It's several months ahead in development. Impala is effectively visible source as opposed to open source. Cloudera has said they're not looking for outside contributions, and you just basically can't change it. Also, up to now, there's been very limited ability to even compile it. Drill, as I said, is considerably behind that. It has a goal of being very open, community-oriented, and much more flexible. Impala has a specific goal in mind of supporting a very specific, narrow range of support. It isn't even Apache Hadoop that it supports. It requires special hooks. Drill wants to be much more flexible.
So I think, unfortunately, we're out of time now. I want to thank you all for coming. If you have other questions, you can come find us. We'll stick around here for a couple of minutes. And then, as we mentioned earlier, we have booths downstairs. So thank you all very much.